How can I solve absolute value inequalities? I'm glad you asked. It's your girl Tiffany with Tiffany's Tutoring and Consulting LLC, guiding you through these education streets. So let's get right to it. So if you're asking, is this a mix of absolute value and inequalities? It is. That's exactly what it is. We're going to go through this step by step. The basis of solving any equation is to, or an inequality, is to know how to isolate your variable and also to understand inverse operations. That's very key. All right, so the first thing we're going to do is we're going to get the absolute value alone, which means I don't want any constants. I don't want any coefficients. I want just the absolute value, whatever's inside of it. So the first thing I'm going to move is subtract 8. Why do I move that? I'm glad you asked. I move that because that's the constant that is furthest away from the variable. So the inverse of subtraction is addition. So I'm going to add 8 to both sides. I'm going to bring down what I haven't dealt with yet, and that's okay. Just bring it down. Bring down my inequality. 4 plus 8 is 12. All right, we're doing great. Now I got to get rid of this coefficient, which is 6. You might be like, well, I don't see an operation. So that should tell you, okay, it's multiplication. Multiplication is an operation that does not require a sign. Okay, so the inverse of multiplication, you got it, division. And you could do the division sign, but I like to show the platform here because that's what definitely you'll see in higher maths. All right, so 6 divided by 6 is 1. Anything times 1 is itself. So we don't have to write 1. You can, but you don't really have to. And then 12 divided by 6 is 2. All right, boom. So now we have our absolute value inequality with nothing in front of the absolute value or behind it. So now, just like we do with absolute value equations, we're going to break this up into two different inequalities. The first one is obvious, right? It's just what's inside the absolute value and then our inequality sign and our number. Okay. We're going to go ahead and solve that since a lot of us are comfortable with this. We're going to do inverse operations. Why am I moving the 3? Because it's the furthest away from the variable. So the inverse of addition is subtraction. I'm going to do my subtraction. All right. Last thing is 2 and t. Again, you don't see an operation sign there. It's kind of like stuck together. That is multiplication. Again, multiplication doesn't necessarily require a symbol. So I'm going to do the inverse, which is division. So I have t is greater than negative 1/2. I'm going to leave it as a fraction. You can put it as a decimal. That's your business, what you decide to do. All right, so now the second inequality. Dun, dun, dun. It's really not hard. What you're going to do is, well, I'm just going to see what you guys do. I'm going to put 2t plus 3 and pause for a minute. See if you guys know how to put the rest of it. All right, we're back. So with an absolute value, we know that originally the number could have been negative or positive because absolute value is the distance of a number from 0. So if I have negative 5, the distance from negative 5 to 0 is 5. If I have positive 5, that same distance is also 5. So I want to make sure I am taking into account my negative answer. So I'm going to put my negative 2. But this is what's going to happen. Here we go. Here we go. We got to flip that inequality. If you remember, when you're doing inequalities and you divide or multiply by a negative, you have to flip the sign of the inequality. So we want to make sure we flip that, and this is our inequality. We're going to go ahead and solve. Inverse operation, again, we're still subtracting 3 from both sides. We have our 2t that comes down. This time we have negative 5 because we had a negative 2. Then we're going to go ahead and look at 2 and t. That's multiplication. So the inverse of multiplication is, in fact, division. So we're going to go ahead and solve for t. So here we have t greater than negative 1/2, t less than negative 5/2. So now let's put it on our handy dandy number line. So it's very important for us to order our number line correctly so that we can see the graphical representation of our answer. So 1/2, negative 1/2 is like minus 50 cents, right? So if you're 50 cents in the hole. But if I have negative 5/2, that's like $2.50. So I definitely want to put my negative 1/2 closer to what would be 0 on this side. And then I'm just going to go ahead and kind of count down to get to my negative 5/2. Perfect. Now, open or close circle. I'm glad you asked. When I have less than or greater than, I'm sorry, and less than, that's going to be an open circle. If I have greater than equal to, less than equal to, that's a closed circle. Okay, same basic inequality properties, right? So here, this is a greater than and a less than. So that's going to be an open circle for both. Then my shading, I shade where my inequality is true. So it says t greater than negative 1/2. So I think of a number that's greater than negative 1/2, that's 0, which is on this side. So I'm going to just shade this way. T less than negative 5/2. So I want a number that's less than, so I'm going to shade this way. And there you go. There we have our algebraic answer. We also have our graphical answer. If you have any questions, let me know. If you want to see other topics, put it down in the comments below. All right, y'all. Thank you for letting me help you. Peace.